Hello, and welcome back to another programming video. In this video series, I'm going to build an authentication service in Actix. There are a couple of new libraries that I want to try, and a few people already asked me to do authentication. So let's see how it goes. The idea is to have a service that will allow the user to create an account and have access to other secure resources. I'm going to do something simple using only JSON Web Tokens, but it will give you an idea on how to implement a more complex setup, like combining it with OAuth 2. In this first part, I will set up the app configuration, the logs, and add a simple help endpoint. First, make sure you have ROS installed. Let's create a new project with cargo new and the name of the project, Auth Service. Go to that directory, open Visual Studio Code, and we will start by setting up our project. We're going to add a couple of dependencies in the cargo.toml file. First, the Actix dependencies, Actix Web version 2 and Actix Runtime version 1, the config crate version 0.10 to load the configuration from the environment, the .m crate version 0.15 to load the configuration from a .m file to the environment, useful during development, Serdi is a serialization library version 1, and we want the feature derived to generate the code for it. Now, I want to try a couple of new libraries to handle and log errors. Air version 0.4, which is a fork of the Anyhow crate, and Color Air version 0.3 to have pretty formatted errors with additional information. Then, Tracing version 0.1. This provides the API to instrument ROS applications to collect structured, event-based diagnostic information. Tracing Futures version 0.2 will allow us to attach the traces to futures. Tracing Logs will add a compatibility layer for the log crate and will allow us to convert logs into tracing events. For this, we will use version 0.1 with the feature Environment Logger, so we can configure the loggers using environment variables. And finally, Tracing Subscriber, that will allow us to add a subscriber to the tracing events and print them in the standard output. For now, this is all we need for tracing, but later on, we can add more libraries on top of this to have something more complex, like distributed tracing or telemetry. Anyway, now let's go to the main file and get rid of the hello world code. Let's first add an import. Use color air result. This result is a type alias for a result of either a type T or an error report, which is a struct that behaves similar to a generic error type. With this, we're going to be able to use the question mark operator to propagate any error that implements the standard error trait. This main function will return an empty result of either unit or an error. Let's make this function async and specify the macro Actix runtime main so it runs in the Actix system. At the end of it, it will return a result OK of unit if everything goes well. Later on, we'll add the code for our server here. But before that, I will define the configuration for the app. Let's create a new folder, config, with a mod file in it. In here, I will define a public struct, config, that will hold all the configuration for my app. I will start with the basic config, a public field host of type string and a public field port of type i32. We'll add more as we need to. I want to get the configuration from the environment variables and load them to this struct. So let's implement config. I will create a public function from env that will return as result the configuration. Now let's add a couple of imports. Again, from color air result, then use Serdi deserialize. And on this config, let's derive the code for debug and deserialize. Then, to make it easier while developing, we're going to import from .m the .m function, and the first thing in our function will be to load the configuration we have in the .m file to the environment. So let's create that .m file in the root of the project. For now, we have the host localhost and the port 3000. Back to the config module, we're going to use the config crate to get the configuration from the environment into our struct. let's define a mutable variable C and assign it a new instance of the config struct from the config crate. This config crate can get the configuration from many sources and merge them in a single place. We only care about the environment, so let's call c.merge and pass config environment default. This will return a result, so let's use the question mark operator to propagate errors, if any. Once we have that, we can call c.tryInto to convert it into an instance of our config struct. Now let's go to the main file and include our config module into the project. After that, we can see we have an error since the result type is not the same. TryInto returns a result of either our config struct or a config error, but I need an error report. So either I use the question mark operator again, or I wrap the config error into an error report. Let's do the latter and add a bit more context to the error. And to do that, we can import a trait. Use error wrap error. With this, we can use the wrap error method on the result or context, which is the same thing. So code.context and let's write a message loading configuration from the environment. And our front-end function is ready. Back to the main file. Let's declare a variable config and assign it config from env. And since it is a result, we could use a question mark operator. But in this case, it is also okay to panic if we cannot load the configuration. So let's call expect and provide an additional message, server configuration. Let's import config. We want our config module, so let's put crate at the beginning. Okay, now we can define our server. It will be an HTTP server. Let's call new to get a new instance, and we need to provide a factory for an Actix application. Later on, we will need to move stuff inside that factory. So let's use move and define a closure. Inside that, we will create a new instance of an Actix application. We will be adding more stuff here later. After that, we need to bind the server to a socket. I will use format to define the socket address. That is just the host, colon, and the port. We can now pass them as a parameter, config.host and config.port. This returns a result, so let's propagate the error with the question mark, then call run to start the server and await with another question mark. Now let's add the import. Use Actix web and we need app and HTTP server. Now save and let's run the server with cargo run. Now the server is running, but I don't see any log message. So let's fix that. First, we need to set the log level using an environment variable. Let's add it to the .env file. The variable is rustlog. Let's set it to debug. Then, in the main file, to add logs to Actix, we need to use a middleware. Let's import it from Actix web. I will add the middleware logger. Now, in our Actix app, we add the middleware using wrap, and we pass the instance of that middleware. I will use an instance with the default configuration with logger default. Let's now configure the tracing logs. Go back to the config module, and in the front-end function, after loading the .env file, we want to configure the tracing subscriber format. This is a subscriber for formatting and logging the tracing data. And to control what to log, we need to add a filter. And we want to also get it from the environment variables. So call with environment filter from default env. This will use the rustlog environment variable. Finally, call init to install it globally. Now let's add the imports. Use tracing subscriber, environment filter. And I will also import a couple of macros. Use tracing info and instrument. Now we can use the instrument macro above the function. This will create a tracing span for the function and will also include the parameters, if any. And we can use the info macro to create a tracing event with the info level and pass the message loading configuration. Now, if we save and run the server again, we will see new log messages. Each entry have the date, the log level, and the context. Auth service is my application, and this message comes from the config module, loading configuration. Now I will go to the .env file and remove one of the required configurations, just to show you what a panic will look like. Run again and we can see the panic. Thread main, panicked at server configuration, loading configuration from the environment. Missing field port. Cool. Now let's go back to the main file again and let's add a log entry when starting the server. Use the info macro, starting server at HTTP, the host and the port, pass them as parameters, config host and config port. Then add the import, use tracing info. Okay, now let's create another module to define the handlers for our app. So let's create a new folder, handlers, and let's add the module to the main file, mod handlers, and a new file, mod. Inside that, let's create a public function, appConfig, and it will receive a config that will be a mutable reference of a service config. Let's import that, use Actix web, and service config. Now I want to define a help endpoint, so I will declare a variable help equal to the web resource. It will be at the root path. For that result, I will define a route. Get requests will go to the help handler. I will import web from Actix web. I can now register a new HTTP service using config.service, and I need to pass the help resource. I just realized I named it the same as my handler, so let's change that to help resource. Cool. Now let's define our help handler. It will be a public async function and will return an HTTP response. Let's use HTTP response OK to have a status code 200. Let's import HTTP response, and that is actually a factory, so we also need to call finish. Now let's go to the main file again, and we can add that configuration to our Actix app. Use .configure and pass the appConfig function we just created. Let's import that, save, and run the server again. To test the server, I want to use Insomnia REST client, but you can use anything, Postman or even curl. I will add a new folder for my OAuth service. Inside that, I will create a new request, call it help, and save it. I also want to define some variables, so I will go to manage environment. I can either create a new one or just use the base environment. Let's add a variable base URL with the value http localhost 3000. Click done, and I can simply use it with two curly brackets, base URL, and then a slash for the root path. Click send, and I got a 200 OK response. If I look at the logs, I can see a new entry coming from the logger middleware. Nice, that's all for this video. In the next video, I will set out the database configuration and models for the users. If you liked the video, hit the like button. Make sure to subscribe for future videos. Thanks for watching.